Hello, I welcome you all in this course on power plant engineering. Today we will discuss the combined operations. In combined operations, the topics to be covered are advantages of combined operations. First of all, what are the advantages? Analysis of load sharing, load division between hydro, thermal and nuclear plants, because mainly we have hydroelectric power plants, thermal power plants and nuclear power plants. Coordination between these three plants. Now, what is combined operation? Now, combined operation. Now, why we choose combined operation? The purpose of combined operation is to provide cheapest power and to generate maximum power with available resources. There are two things: generation of maximum power and cost of the power. So, both the cost of the power has to be minimum, generation of power has to be minimum. That is why combined operations are done. Now, what are combined operations? Combined operation means, suppose in an area the requirement of power is 1000 megawatt. Now, if we go for the 1000 megawatt hydropower plant, suppose hydropower plant we want to use for this purpose, but this 1000 megawatt requirement is only for 2 months. Remaining period, the requirement is, let us say, 600 megawatt. So, if I make 1000 megawatt hydropower plant, then most of the time it will be underutilized. And you know, in hydropower plants, a dam has to be made. So, I will have to make a dam of higher capacity. So, the cost will increase. So, what I can do, I can make a 600 megawatt plant and 400 megawatt for 2 months can be met with a thermal power plant or nuclear power plant, right. So, this is known as combined operation, right. So, the combined operation also ensures the continuous power. Suppose this hydropower plant fails, we have 400 megawatts of thermal power plants, at least we can continue to supply some of the power. But suppose solely I am dependent on the hydropower plant, something goes wrong with the hydropower plant, then there will be no power at all. So, the combined operations, they ensure first of all continuity of the power supply, integrity of power supply, and third is security of power supply. These three things are ensured by a combined power system. Now, combined operation system. Now, what are the advantages? So, some of the advantages I have already discussed with you. Now, advantages of, first of all, it is reliable. Second, it avoids complete shutdown, as I said earlier. So, avoid complete shutdown. Number 3, overall cost is less, because we are taking a combination. Instead of going 1000 megawatt of hydro, we are going only 600, because hydro power plants, the fixed cost is very high. I mean, installation cost is very high. Once the plant is installed, then running cost is very, because no fuel is required, only water is required. So, running cost is, so the power is cheap, but initial cost is high. So, overall cost is less. In case of combinations. Number 4, or we can say less capital investment, more of the same thing. And supervision and maintenance, this cost is also reduced. So, there are so many advantages of combined operations. Now, load division. How we will share the load? Load division between the power plants. So, there are two types of loads. One is base load, another is peak load, right. Suppose month wise power consumption, energy consumption is suppose is not like this. Next, month wise, suppose month wise energy consumption, first month, second month, third month, it is like this. So, this is the peak period, maybe for 2 to 3 months, right. So, this peak period we can go for, instead of going for the hydro, we can go for some other power generation method, so that the cost is reduced. But it is not depicted normally in power plant. When we depict the data, it is always a cumulative frequency, okay, for 1 year. In 1 year, how many hours are there in 1 year? 8760. 8760 hours, right. So, we go by cumulative frequency, and now we can say for example, this one, this is the base load, this is the base load, this is kilowatt. So, area will give you the new unit, kilowatt hours. So, this is the base load and this is the peak load. For this duration or for this much of hour, we require additional power or over and above power of the base load. Now, what are the requirements? What are the basic requirement of a plant to supply power in the base load, right? So, requirement of a plant for base load. First of all, as I said earlier, minimum operating cost, hydro. In hydropower plants, the operating cost is minimum. Fixed cost is high, but the operating cost is minimum. Continuous supply of load, that is there is a continuous supply. Capital minimum, they all go in favor of hydro. Capital cost minimum, maintenance is minimum. Hydropower plants have minimum maintenance. Thermal power plants have maintenance cost is high because it works on high pressure, steam is there, steam causes erosion and corrosion, valves are there, valves have to be replaced frequently and not frequently, after a certain interval of time. So, the maintenance and the boiler has to be maintained. So, the maintenance cost of thermal power plants are higher than the hydropower plants. So, this also goes in the favor of hydropower plants. 5. Location. Now, base load plant should be close to the load. So, that is that goes against the hydropower plants, because hydropower plants have restriction that there has to be a continuous flow of water. So, the base load plant should be close to the, otherwise transmission losses will be there. In our country, transmission losses are already 30%, 30 to 40%. So, the location is very important, right, and that restricts the use of the hydropower plants in many of the locations. And number of the operations required should be minimum. So, hydropower plants, the number of operations, because if you go for a thermal or the nuclear plant, the number of operations are very high, right, if you compare with the hydropower plants. Spare parts, availability of spare parts. I think everything goes in favor of hydro except the location, because hydropower plants are restricted by because we cannot install hydropower plants anywhere until unless they can be installed only on those locations where flowing water is available, right, because the power is generated with water. So, rainwater can also be used for hydro generation, but not for the high capacity. For very low capacity, rainwater can be stored in a pond and the hydropower can be generated, but that is for a short duration of time, not for long duration of time. Steam power stations. Now, steam power station, the best, that is thermal power station, thermal power, steam or thermal power, right. Capital investment is less. right? But operating cost is high, right? So, capital investment is less, can be located near the load. Steam power plant can be located near the load. There are no issues. Only availability of coal is concerned, and coal can be transported by the railroad. So it can. So location is and gestation period is also less. I mean, if you compare with the hydropower plants rehabilitation has to be done. The construction period is quite high if you compare with the thermal power plants. They can be easily installed near the load, and the power can be generated. Running cost is high, that is true, and maintenance is slightly higher. As I said earlier, the thermal power plants, periodic maintenance is required. So that is the additional financial burden in case of thermal power plants. Now, there are other type of steam power. I am talking about a thermal power plant where steam is used as a working fluid, or the power plant that were typical thermal power plant which works on the Rankine cycle. Now, there are thermal power plants which work on diesel cycle also, or diesel power plants. First of all, their generation capacity is not very high. We cannot go for high capacity diesel power plants. And if we go for high capacity diesel power plants, the maintenance will shoot up. So that is not desired. So they are not suitable as a base load plant at all. We can go for the peak load. For certain duration of time, we need certain power. In that case, we can go for the diesel cycle or diesel power plant, but not as a base load power plant, right? Another is nuclear power plants. Its initial cost is very high. Nuclear power plants is high technology plants. The initial cost is high. And running cost can be compared with the thermal power plant, but initial cost of nuclear, that is why the cost of the energy generated in a nuclear power plant, I mean the cost per kilowatt hour is slightly higher than the normal thermal power plant in case of nuclear power plant. And second is limited availability of the fuel. Fuel availability is the main issue in a nuclear power, fuel availability and disposition of used fuel. These are two more limitations in case of nuclear power plant. As a base, so we will say that if the location permits, in that case the hydropower plants are the best option, being used as a base load plant. Now, regarding the peak load plant. Minimum cost. The cost of the plant should be minimum, because the peak load plant will work for only a certain duration of time in any year, right? Low operating cost. So operating cost for any machine, it is always desired that it should have the minimum operating cost. So is the case here. This is important. Cold start time. I mean, the moment the power is required, immediately the power plant should start producing the power. So cold start plant, if you look at, then the diesel power plants are the best. You press the button and the power is generated. So they have minimum cold start time. And number 4, quick change response to load change. So peak load will keep on changing. Base load will remain constant, but the peak load will keep on changing. So there has to be quick response of the power generating machine for the change in the load. Now, in this case, as I say, diesel power plants, easy to cold start. As I said earlier, it is the best option if you have to consider only the cold start. Now, auxiliaries are limited. Diesel power, say for normal steam power plant, auxiliaries are required. First of all, you have to start the pump. So a system is required to start the pump, right? Then you have to ignite the boiler. But here in this case, just you press the switch and the power will be generated. So, auxiliaries are not required and it has good overload capacity. Good overload capacity and thermal efficiency is also good for diesel power plant. So, but the limitation is that we cannot go for very high power with the diesel power plants. And nuclear plants, they cannot go for the peak load plant because nuclear power plants, they produce constant power. So, they are never recommended for the peak load plant. They are always recommended for the base load plant. That is why you will find we have nuclear power plants of very high capacity and this high capacity is used as the base load in any power combination. Now, load sharing, how to share the load? So, we have two types of power plants, base load power plants and peak load power plants, and load has to be shared between these two power plants, right. Now, suppose in a year, we 8760 hours, right, and the variation of load is like this. There is certain variation in the load. This is the peak load. Peak load may remain say for 1 hour or 2 hours, right. This much load will remain for this duration of time. This much load will remain this duration of time. So, duration and load curve we have drawn. This is the power in kilowatts, right, and this is the H hours per year. Suppose this load, this will remain H hours per year, right. So, we choose certain base load. Suppose let us say this is base load. Somewhere we have to draw a line. You can take base load as this. In that case, during remaining period, the plant will be underutilized. If you take base load this, in that case, peak load has to work for a longer duration of time. So, some optimum value has to be realized, right, between peak load and base load. Now, annual cost R1. Suppose this is a base load line. Above this, it is peak load, and at this one AB is, or XY is, or X1, X2 is base load line. So, the cost is something fixed cost, some fixed cost plus capacity wise. If you increase the capacity, the cost will, so there has to be constant for the capacity. If you keep on increasing the capacity, this cost will increase plus tariffs. So, there are three things. First is fixed cost, another is cost dependent on the capacity of the plant in kilowatts, and the third is cost as per the energy generated, right. Now, this is plant 1, this is from plant 1 and this is from plant 2. Suppose this is hydro plant, this is thermal plant. So, plant 2 is again A2 plus B2 plus C2, right. Now, for operation practically, if you compare these two equations, the C1 has to be less than C2. Unit cost in base plant has to be less than the unit cost in the top plant or the peak load plant. So, C1 has to be less than C2. When C1 is set and B1 has to be greater than total cost. When you are operating at this point, what is the total cost? So, total cost R1 is equal to A1 plus A2 plus B1 plus B2, sorry, not B1 plus B2, it is B1 kilowatt, this is base plus B2 kilowatt peak. They are different. Kilowatt, this is base kilowatt, this is peak kilowatt. Because R1 we are using, 1 is we are using for the base plant, 2 is you are using as a peak plant. So, B1 kilowatt base plus B2 kilowatt peak, right, plus C1 plus C2. Why I am taking area? This is kilowatt multiplied by, if you take the area of this, it will give kilowatt hours, right. So, area base load plus area C2 area peak. Now, this is the cost. Now, there is a change. You increase d kilowatt, as we do in mathematics, you have changed the baseline. Now, the baseline is this. Now, when the baseline is this, d kilowatt is added, some differential of kilowatt is added. When some d kilowatt is added, then R2 is A1 plus A2, this is going to remain same, plus B1 kilowatt plus d kilowatt base, right, plus B2 kilowatt plus d kilowatt peak, right, plus C1 d kilowatt into H, because this is H. So, we will take the area d kilowatt into H. So, this area will be added, and from here this area will be subtracted. So, it is going to be C2 A peak A peak minus A peak d kilowatt into H, right. We have, what we have done, we have just added these two, we got the total cost. We added R1 and R2, we got the total cost A1 plus A2 plus B1 kilowatt B1 plus B2 plus C1 plus C2, okay. Kilowatt hours, we have taken the area of the graph. Now, next cost, when there is a change in the d kilowatt, right, then the next cost A1 plus A2 will remain same, fixed cost will increase. So, we have added running cost C1 is going to be this area plus this area, and C2 this area minus this area. Now, if you take the difference and solve these two simultaneous equation, and for optimum condition, the H has to be B1 minus B2 by C2 minus C1. You just take the difference and make it 0. R2 minus R1 is 0. So, then you are going to get the value of this. So, the value of H is B1 minus B2 divided by C2 minus C1. Now, regarding this, now we will take combinations. Now, combination is, first combination we are going to take is hydro and steam. And hydro, this is storage type. Storage type of hydroelectric power plants means there is a water reservoir. It is not a runoff type of, there are two types of hydroelectric power plants, one is runoff type and another is storage type. In runoff type of, there is a continuous flow of water and power is generated. In that case, it has to be ensured that throughout the year there is continuous flow of water and there is not much variation in the flow of water. Another type of hydro plant that we store the water during rainy season, and that stored water is used for the entire year. As we do in our country, you will find many of the hydropower plants, they are dam based power plants, okay, or storage type of power plants. So, hydro plus steam, in hydro will be based, steam will be peak, right. During drought period, when there is no water, the situation may reverse. The steam power plant may become the base power plant, and the hydro plant, because it is generating the less power, it may become the peak load power plant. But we should remember that thermal power plant are costly to run as a base load power plants, right, if you compare with the hydro power plant. And if you want to have predominantly hydropower plants, then you have to go for runoff type of runoff river plants. So, as I said earlier, in runoff river plants, the flow of water, continuous flow of water has to be maintained, right. So, their scope is quite limited. So, and then we have predominantly thermal plants. Predominantly thermal plants means thermal power plants, they work as a base load plant. So, in a geographical location where we cannot use hydro energy, naturally thermal power plants are going to be the base load plants, or cost of storage of water is quite high, or running cost or overall running cost of hydro plant become very high. In that case, we have to go for the thermal power plant. Okay, we have to go for a thermal power plant as a base load plant. There is another system that is known as pump storage plant. Now, in pump storage, what happens? Suppose in a in a hydro plant, the requirement is suppose 200 megawatt and capacity is 300 megawatt. So, this difference of capacity is used for in a pumping station to pump back the water, right. So, that when in future when the demand remain constant, but the supply of water is reduced, in that case this energy can be used. So, these type of power plants are known as pump storage plant, and they can be used in combination of nuclear power plants. Nuclear power plants are never a peak load plant, they are always base load plants, because nuclear power plants, the power generation is constant, that does not change. So, in nuclear power plants we can go for the pump storage type of plant as a peak load plant, but not as a base load plant. Now, gas turbine station, gas turbine is also one of the thermal power plants, gas turbines. So, hydro plus GT, hydro plus gas turbine plants. Now, the gas turbine plants is, they are easy to fabricate, they start quickly, and this gas turbine can be used when the peak load is less, is a small amount of energy. Suppose the power plant is the requirement goes like this for the year. In that case, for this period we want some additional power. So, they cannot contribute in a substantial manner. So, when the peak load requirement is small or not very significant in comparison to the base load, in that case gas turbine type of plant can be used, where the load factor is less than 50%, 15%. We can have gas turbine plants in the 10 to 25 megawatt capacity. Okay. Capital cost, if you compare the capital cost, it is 1000 to 1200 per kilowatt hour for gas turbine power plant. If you go for the steam, it is 1600 to 2000 per kilowatt hour. Thermal efficiency of gas turbine power plant is less as compared to the steam power plants, because gas is being used as a working fluid. So, the discharge of energy is quite high in case of gas turbine power plant. But they claim certain advantages also, gas turbine type of power plant. Less space, they occupies less space, power density is high, right. Heavy foundation is not required, right. Short time construction, gestation period is less. Cooling water, less cooling water is required. If you compare to the steam power plant, the less cooling water is required in the gas turbine power plants. Less number of operations. And quick response. These points, they go in favor of gas turbine power plants. So, if we want to coordinate between coordination, if you want to look at the coordination between different plants, first of all, the points to be taken into consideration are initial capital cost, second fuel cost, third is operation and maintenance cost, चौथा fuel availability. Suppose you are going for nuclear power plant, then you have to ensure the availability of the fuel as well. Economics, peak and base type of plants, what should be the capacity of the peak load plant, what should be the capacity of the base load plant. Working characteristics, and transmission. Transmission of power is also important. Suppose you generated a power in a place where load is far away. So, transmission of power is also important, that transmission of power should take place in minimum of energy losses, right. So, this is how, and these are the points which are to be considered while we develop coordination between different type of power plants. That is all for today. Thank you very much.